The question is, which sequences converge to a limit as n approaches infinity? And that idea of converge to a limit means they actually produce a number when you say the limit as n goes to infinity of a sub n, or b sub n, or c sub n. So what we're looking for is sequences that do not explode out to infinity as the answer, something like n over 1, that would just tend to infinity. And we're also looking for 0 to not be in the denominator, because if 0 is in the denominator, then you have a does not exist or an indeterminate situation. If we look at n plus 8 times n plus 1, which if you see my mouse, it's moving over the A option. The fact is n will distribute to make n squared plus some things that are not n squared, and that happens on the top and the bottom. So therefore, we're left with really n squared over n squared as n explodes to infinity, and they'll ultimately cancel out. So in this problem, A does have a limit. It's not 0, but it's also not infinity or does not exist, so therefore we'll allow it to happen. E to the power of n plus 1 over e times n plus 1. E to the power of n is an exponential, while e times n is some sort of like scalar linear value. So therefore, an exponential is going to overpower a linear function as n is dramatically, emphatically large, so B is not the right answer. And the same answer, the same logic is true of part C, that n squared is going to take over n in the fact that on the top of c sub n is n squared and the bottom, the denominator, is n. Eventually, as n gets so large, the bottom won't even matter, and the answer to that one will be infinity. So therefore, I'm saying A is the final answer. Well, that's all of these I'm going to do.